This is the map every new pilot must learn before they fly. It's huge! You need an engineering degree to follow these things. As a new pilot, you must learn to use and navigate with this map when you're doing your solo cross countries, when you're doing your flights, especially when you go do your check ride. Most likely, the examiner will not allow you to use any form of electronic, so you're gonna have to bring a current, unexpired map. These are called sectional maps because every one of these maps cover a different section of the United States. This one covers New York, as you can see right there. I will cover the basics in this video as a VFR pilot of what the different symbols on the map means, but you can see there's a legend, a comprehensive legend here that you can also reference and study on your own. But I'm just gonna go through the map and kind of show you a couple things here and there. But if you pick up a sectional, you do have a reference to the legend if you want to get into a lot. Let's begin. Here I have the New York sectional, and if you look at the effective dates here, this map is effective April 25th through November 7th, 2019. So if I were to fly this with this map today, I would not be flying with a map that is current. There may be some airspaces that may have changed, and it is not a good idea, especially if you're working on your check ride, because the examiner will look at all of your information, all of your material, to make sure that you are flying with the most current and up-to-date information and material. But for the purposes of this video, we can use this map as we're not going to focus so much on the accuracy of the data, but rather what each signal and each area signifies and what they mean. So the very first thing that you'll notice when you open the map is these very large circles, right? And you find them all around in all different types of circles and lines. And when I first started aviation, I was so confused. I had no idea what everything meant. But here, I'm gonna break it down for you. So these large blue circles indicate that this is a Bravo airspace. And typically a Bravo has multiple blue solid rings, one inside the other. Being that this map is from New York, this is Newark, this is New Jersey, this is New York City over here, and this would be considered JFK. So this is JFK. Where are you? Right there, JFK. This is LaGuardia, and this is Newark. And if we zoom out here, you'll see that the outer ring is this blue ring here, which basically tells you that Bravo airspace in this outer ring up until this inside ring starts at 3,000 feet and it goes up to 7,000 feet. If we go in to this ring, it goes from 1,800 feet up to 7,000 feet. If we go in further, 500 feet up to 7,000 feet. And inside goes from, from the surface up to 7,000 feet. So if you are flying in this direction, for example, this is a flight that I did from Somerset Airport up to Stewart Airport. I crossed the Bravo right here in this little space, and I was okay if I was below 2,500 or 3,000 feet. So I was actually cruising at 2,500 feet here. But then I needed to climb up to my cruising altitude of 4,500. So I contacted Approach, and I got clearance into the Bravo past 3,000 feet up to 4,500 feet, which was my cruise altitude. The next airspace that is a little smaller than the Bravo is the Charlie. Here's a Charlie airspace here. And this is Allentown, and Charlies typically have 2 rings. Okay, so in the inner ring you got from the surface up to 4,400 feet, and in the outer ring you have from 2,800 up to 4,400 feet. So this is a Charlie airspace. The next one that's a little smaller is the Delta airspace, and this would be a Delta up here. So this is a dotted blue line. That's how I like to remember it. Delta D equals dotted blue line, and there's only 1 ring, and it starts from the surface up to 6,000 feet. There are different requirements when it comes to entering the Bravo, the Charlies, and the Delta airspaces, but I won't cover that in this video. I'm going to save that for a different video because that has to deal with communications and approaches, and this video is mostly focused on how to read this map. Other circles that you'll find in this map are these circles that look like a bunch of radios, and these are VORs, very high frequency omnidirectional radios, and this is what they look like. These VORs, that's the sign of a VOR. Here's another sign for a VOR. Here's another sign for a VOR. And basically, these are used to assist pilots in navigating to these locations. So for example, this is my home airport, Somerset Airport. Notice how there's that ring around Somerset, and right below that you'll see Solberg Airport, and that little dot inside the airport indicates that's the location for that VOR. So if I'm flying around here and I find myself lost in some way, I can actually tune in to this VOR, and I can follow this VOR, and it will bring me to this location. Now, very similar to how to do approaches into these airspaces, I'm not gonna cover how to use a VOR. I'm gonna save that for another lesson, but know that these large circles with these radios that look like a big clock, these are used for navigation purposes. Okay, something else that you'll find in this map that is obvious, you'll see a bunch of different airports. It's like that's an airport, that's an airport, that's an airport. If I scan through this map, there's an airport, there's an airport, 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 airport. So look how many airports there are here. Tons and tons of airports. Now, there are airports that are magenta, and there are airports that are blue. The difference between the magenta and the blue is the magenta airports are untowered airports. The blue airports are towered airports. So this airport here doesn't have a tower, doesn't have a tower, doesn't have a tower. Tower, there's a tower. And notice that the towered airports are surrounded by some sort of Delta airspace or Charlie airspace or Delta airspace, Delta airspace, etc. But that's the difference between the magentas and the blue airports, is that blues are towered, magentas are untowered.
In addition to the towered and non-towered airports, you also have private airports, and they are depicted with the R in the circle. So all of these R's are privately owned airports. There's not much information on these airports. Basically, you're not allowed to land on these R's or these airports here unless you have an emergency, and they don't even publish much information like if the runway is paved asphalt or if it's grass, or really what type of length you have to work with. Like, there's really nothing published on these private airports. Let's take a closer look at a towered airport. This is Wilkes-Barre Scranton International, and you know that this is a delta because it's surrounded by this dotted blue line. If we zoom in a little further here, there's the name of the airport, Wilkes-Barre Scranton International. Alpha Victor Papa is the identifier for this airport. To the left, we start with, I'm not sure if you can really see this, but this is a CT, which stands for controlling tower. So the tower frequency is 120.1. The ATIS is 111.6. That's how you get your weather. The tower, or the airport rather, it's located at 900, that's a 962 feet above sea level. The L means that the tower has, the runways have light for night operations. 7.5 is the longest runway, so 7,500 feet is the longest runway. And 122.95 is the Unicom frequency. Now, when you look at an airport like this, you see that there's a longer runway running from north to south, and then there's a smaller runway running east to west. This is actually a depiction of what it would really look like if you were to fly into this airport. So you would actually see, if you were coming south to north, if you were flying northbound, you would see this same layout as you're approaching the airport. So, and that's true for all the airports on the map. So all the airports are actually in the map, are depicted in the direction that the runways were built in real life. Something else that you'll notice here is this star. Okay, so this star on top of the airport signifies that there's a beacon. So the tower has a beacon light for easily identify the airport at night or during IFR conditions or bad weather. Okay, all the yellow that you see here, these are populated areas. Okay, so anything that you see highlighted in yellow, these are populated areas. And it's very important to be familiar with the shape of the yellow, because at night, when you are approaching this airport, you would actually see the same layout for all the lights in the city. And that's how you know that that's another indicator that you are approaching the correct airport, and kind of gives you a good perspective on where you are in space. We spoke briefly about the VORs, okay, the very high frequency omnidirectional radios, and remember, these are the ones that look like a clock. So here's a VOR right next to the Wilkes-Barre airport, and the VOR here is located right there in the center, and this box has the VOR information. So this is the Wilkes-Barre VOR, and then you would tune on your navigation radio 111.6 to hear this Morse code and identify the VOR. And this channel 53 is for military operations. But basically, this is the identifier for this VOR, and you can tune into this VOR and navigate to it. That's another way of approaching or navigating to Wilkes-Barre. This large gray circle is a TRSA, TRSA, or a Terminal Radar Service Area. That's what this is. Now this inner, I guess magenta transition-like lines, this is a Class E, so anything inside this circle is a Class Echo airspace.
but it's class Echo that starts with a floor of 700 feet above the surface. Okay, everything else outside of this area, class E starts at 1200 feet, but in here it starts at 700 feet. Now, if you zoom in, you'll find this dotted magenta line. This is class E starting from the surface. Okay, so class E airspace is a little bit different than the rest because you have from 1200 feet out here, starting from 700 feet inside this transitional magenta line, and then you have from the surface inside this dotted magenta line. There are some sections where you'll see this airplane looking like shape here. These are lighter vehicles, so the U stands for ultralight activity. Here's a G. G stands for glider operations. You may also see some with an H, which stands for hang glider activity, or UA for unmanned aircraft activity. And if we look around the map here, sometimes you'll find a parachute. So these are parachute jumping areas. So you just want to be mindful of these sections here if you're flying around these areas. Another important symbol on the map, especially if you're flying VFR, are these little flags here. These are checkpoints, and this is the name of this checkpoint, Kutztown. And this is important because if you're flying VFR and you're not sure where you are and you're speaking with an approach or tower, you can tell them you're near Kutztown and they know exactly where you are. The big circle with the X, this is not part of that checkpoint. This is actually an abandoned landmark. Okay, that's what that is. And I believe there's another one here. Yep, there's an abandoned landmark. Something else that I wanted to mention on the Class Bravo airspace is that you'll see this thin magenta line going all the way around it. And this is a Mode C area, and it tells you 30 nautical miles from the Class Bravo airport. You basically need to have a Mode C transponder if you're gonna fly anywhere in this area here. So the airport that I fly out of, actually both airports, Solberg and Somerset, all the aircrafts that operate in this space, within these two airports, all have the Mode C transponder. Something else that I'll cover here is you see this very long magenta dotted line that basically crosses the entire map. This is the magnetic variation, and this is 12 west, so 12 degrees west. So the world, it has a true north, which is the actual north, but then there's also magnetic north, and the compass and our navigation tools, they really use the magnetic north. So if you're doing flight planning, you need to account for this 12 degrees in order to do your calculations correctly when you're going from point A to point B. It really doesn't matter much if you're going from very close distances, but if you're going, into a far distance like this or like this, you need to make sure that you do your calculations correctly so you can head in the right direction. I'm gonna cover how to complete a flight plan in a different video. That's it for now, amigos. Leave me a comment, a message, and if you like this video, hit that like button, subscribe to my channel. It really helps. Ciao.